Hello everyone, this is Anusha Kolli, working as an assistant professor in the Department of Computer Science and Engineering in Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about the topic Introduction to Compilers from the subject Compiler Design. Let's move on to the topic. What is a compiler? Generally, we write the programs in high-level languages like C, C++, Java, and Python. These languages doesn't understand by the computer. Why? Because the computers only understand machine languages. So machine language or binary instructions. So there should be someone to translate these high-level languages to machine language. This is where a compiler comes into picture. A compiler is a software that translates a program written in high-level languages such as C, C++, Java into machine language that can be directly executed by the computer. Imagine two people were speaking in two different languages. One person speaks Telugu and other person speaks Hindi. They can't communicate directly or they can't understand directly. So they need a translator. What the translator do? Translator listens to the first person and translates the language and explains it to the other person. Here, the compiler acts as a translator between the programmer and the computer. The programmer writes the code and the compiler converts the code. Compiler converts it and the computer executes it. And see the picture here. So user or programmer writes high-level languages like C, C++, Python or Java, and these programs are given to the compiler, and compiler converts these languages into some intermediate or low-level assembly language, or we can also call it as machine language. And along with that translation, compiler also performs report handling. The compilation is the process of checks the programs for errors and converting the source code into some equivalent machine or target code. So if your program doesn't have any errors, and we will get an executable code, or if your program contains any mistakes, and those errors will be reported by the compiler along with the line numbers. Let's discuss about the types of compilers, what does it do and where it is used. Let's start with the first one, single pass compiler. This single pass compiler reads the source program one time and immediately generates the equivalent machine code, and it doesn't go back to check the previous instructions. Let's take a simple example. Int a is equal to 10, int b is equal to 20, and int c is equal to a plus b. So assume that this is the source code. Compiler first reads the first line, then second line, and then third line. And it never goes back to check the previous lines. This is single pass compiler. And coming to the multi-pass compiler, the compiler compiles or reads the program multiple times, which means more than one time. For example, each pass of a compiler performs one phase of a compiler. For example, in the first pass, the compiler performs lexical analysis. In the second pass, the compiler performs syntax analysis. In the third pass, it performs semantic analysis. In fourth pass, it generates intermediate code. In the fifth pass, that code will be optimized. In the sixth pass, a machine code or assembly code will be generated. So here in the multi-pass compiler, compiler reads the source program multiple times. Coming to the cross compiler, this kind of compiler runs on one computer and generates target code for another computer. For example, Cross compiler. Cross compiler runs on one computer and generates an executable code for another computer. If we take an example, if you want to develop a mobile application, you write that application code on your Windows laptop and that can be compiled and you will get an executable code. That code you will use for your Android phone. So that is a cross compiler. And coming to the native compiler, these types of compilers runs on computer and generates an executable code for the same computer, which means that, for example, if we write the C source code that is printf hello. So assume this is the C source code, and this source code, whenever the C compiler compiles this source code, you will get some .exe executable code, and you are writing the code on the same computer and you are executing the code or you are running the code on the same computer, which means here host system or host computer and the target computer both are same. Coming to the Bootstrap compiler. Bootstrap compiler use the same programming language to compile its programs. For example, initially Bootstrap compiler. This compiler compiles Bootstrap compiler, and this kind of compiler uses the same programming language to compile its own programs. So for example, if you want to design a C compiler, initially the C compiler version 1 was written in assembly, and then later the C compiler version 2 is written in C language, and then this C language compiler is used to compile its own programs. Those are written in C language. These kinds of compilers are called Bootstrap compiler. And the next one, just-in-time compiler. These types of compilers doesn't compile the entire code in one time and before execution. Just-in-time compiler means it doesn't compile the entire code before its execution. So whenever it is needed during execution, it compiles the necessary part of your program. And coming to the next one, ahead of time compiler. These types of compilers compiles the entire program before its execution, and which means that before execution only an executable code will be ready with the help of these compilers. And the last one is optimizing compiler. Optimizing compiler optimizes the executable code or machine code without changing output of the program. So that is the optimizing compilers. Let's talk about a language processing system. A language processing system is a collection of tools that work sequentially to translate human-readable high-level source code into machine executable code. Why? Because the computer can't directly execute high-level instructions like C, C++, or Java. They only understand binary zeros and ones. As we already know that computers doesn't understand the high-level languages which are written by the humans or the programmers. The computer only understands binary zeros and ones. So here the language processing system can be used to convert the program which is written by the programmer into machine code or binary instructions. And see how the language processing system can be used to convert a source code into machine code. See, initially when we write a program in any high-level language like C, C++, or Java, we call it as source code. And initially that source code will be given to a preprocessor. There will be a preprocessor that will be used to process the instructions given by the user. This preprocessor processes all the source code and it removes. If your program contains The pre-processor directives like hash include stdio.h, or if you define any symbolic constants like hash define pi is 3.14. If your source code contains these kinds of preprocessor directives, hash include stdio.h and hash define pi is 3.14. This eliminates or removes this statement and includes necessary declarations or necessary files which are required from stdio.h. And if your program contains hash define pi value is for like symbolic constants which replaces the symbols with their values. And so here the preprocessor will take the source code as an input and it will remove these kinds of statements in your source code and gives you the expanded or pre-processed source code. And this pre-processed source code doesn't contain any preprocessor directives and symbolic constants. And this pre-processed code will be given to a compiler. And we already know that compiler is a translator that converts the source code which is given by the programmer into equivalent target code or binary code. And this compiler, usually the compilers converts source code into an assembly code. And these assembly code might have the instructions like move, add, load, these types of instructions. And the compiler will take the pre-processed source code and gives output as an assembly code and produces an assembly code. Here the compiler produces an assembly code and that assembly code will be given to assembler. Here assembler takes assembly code and converts that assembly code into equivalent machine code. And equivalent machine code. This machine code is directly understood by the CPU. And this machine code will be given to the linker. Here, if your program contains large set of instructions or multiple lines, that program is divided into multiple files, file 1, file 2 and file 3. Here the job of linker is to combine all these files into a single and executable file. A single executable file will be created with the help of a linker. Later, this executable file will be given to the loader, and the job of loader, as we know that initially when we write the programs and say those programs will be stored in the secondary storage of your device, and to execute that programs they has to load into the main memory of your computer before its execution. So the job of loader here is to load the programs which are in the secondary memory to the primary memory of your computer, so that from the primary memory the CPU can easily execute the instructions. And the loader loads the programs into the memory. So this memory is called primary memory. And from that memory, the CPU can take the instructions and easily execute the instructions. And we get the output. In this way, the language processing system can process the source code, and finally an executable code will be generated. Here the source code, let's see the sequence. The source code is given to the preprocessor. The preprocessor will remove the preprocessor directives and symbolic constants, and it will give the preprocessed source code to the compiler, and the compiler translates the source code into assembly code, and later assembly code by an assembler gets converted to machine code. And this machine code, with the help of linker, all the files, small files, will be combined and one executable file will be generated. And this file will be loaded into the memory with the help of loader. Finally, these instructions are ready for the execution by the CPU, and the CPU will execute the instructions and we get the output. And this is the language processing system. Every program has to pass through all these phases before its execution. And this language processing system consisting of set of software tools. With the help of all these tools, a program gets converted from a source code to machine code. This is how in every programming language and every program should convert it from a source code to target code. And these are the references for the above content. Thank you.